Welcome back to Section 4 of the Student Machine Learning Coalition course. In this section, we're covering Python's library of Seaborn, and in this module, we've already covered distribution and matrix plots. In this section, we'll be covering the last three parts of the table of contents, namely categorical plots, grids and style, and finally, regression plots. Let's get right into it with categorical plots. Now, self-explanatorily, the name categorical plots implies that these graphs were separating based on category, and we can see that with our first graph, the bar plot. The syntax for this is sns.barplot, x equals column name, y equals column name, and data equals data frame name, similar to the majority of the plots that we worked with in the previous sections. What the bar plot does is it takes one value, the sex in this case, this x column, and creates the categories of male and female. Then it takes the second value, y, which in this case is a count of some sort, and takes all the values in each different category and averages it. Of course, it uses this with respect to the data frame, these column names of course. Bar plots average data and aggregate data based off the mean. This is quite different from our next graph, the count plot. Now the count plot actually counts and only needs one variable input. It's sns.countplot and then x equals column name and then data equals data frame name. It's similar to a bar plot but gives value count instead. These categories are already predetermined because the data goes through and the code goes through and ensures that there's only going to be two categories, or any more depending on the actual data frame. Then it counts the amount that these categories appear in the data frame. In this case, we found that there are around 160 males to maybe around 90 females. The count plot is perhaps the most simple example of a categorical plot, and you can use it in many ways, especially when simplifying your data. Let's go into the third and perhaps one of the most common types of graphs that we use in real life, a box plot. Now box plots, like regular box plots, display the median, the first quartile, the third quartile, outliers, and the general distribution of your data for a certain interval. For box plots, we graph them on respect to two data frames or two variables. That's why for box plot, it's sns.boxplot, x equals column name, y equals column name, and data equals data frame name. That's because we obviously need one, like in this example day, we need something to graph on, and then we need something to graph with, which is the total bill. A useful tip to know with box plots is you can sometimes actually do entire data frames depending on the specificity of the data frame. You don't even need to clarify x and y. This is useful when doing wide ranges of box plots for different variables. In this case, as you can see, we've used the day as the x column and total bill as the y column, creating box plots with different variables and different distributions based on the day. Now this next plot, the violin plot, is quite similar to the box plot. As you can see, they even have similar distributions for these same exact variables. However, the violin plot shows distribution on a horizontal axis. As you can see, it increases in size when we come near to the median, and it decreases in size as we see less and less of the certain outliers and other values. The syntax for this is sns.violinplot x equals, y equals, and data equals. Exactly same to the box plot. Obviously, it graphs on respect to two variables, in this case total bill and day. And it represents occurrence, and it also has a KDE. Next, let's look at another categorical plot, the strip plot. The strip plot, again, is kind of similar to a scatter plot, but split up among different categories and only graphed on one line. The strip plot is the same syntax as the previous two plots. sns.stripplot, x equals column name, y equals column name, and data equals data frame name. As you can see, it shows dots wherever the data is more dense. As you can see in this example, like the violin and the box plot, it shows a density of dots near to the places where we've seen the boxes, or where we've seen the thickness in the violin plot. Just again a clear example of how this categorical plots also have some method and level of distribution. Now, the fourth section of the Seaborn course will be going over grids and style, or how to manipulate and change the colors and change the ways that your grids appear in these graphs. Now, obviously, for the majority of these graphs, we've been using a basic color the basic color scheme, with green, yellow, green, orange, blue, and red. But you can change the hue, you can change the way these graphs are being represented, and much more. Let's go exactly with what grids are. Now, grid type plots overlay different types of graphs using different columns of a data frame, and it uses the same plots as other sections, but best formats them. Grids are a type of plot. but they are a fancy way of showing many, many plots over one area. Take, for example, the pair grid, which is perhaps the most useful way to use a grid. It's first you create a grid using sns.pairgrid and then say the data frame name. And then you do the variable name that you've mapped this grid to, and then you say map sns.scatterplot. Usually what would happen is you say x equals sns.pairgrid of a data frame, then you say x.map, and then you put in parentheses what type of data frame or what type of code or graph you want to look like. In this case, we've used a scatter plot, and as you can see, it creates a entire pair grid using scatter plots. Again, like the joint grid, using different variables in respect to other variables in creating a matrix. Take, for example, this bottom left graph, which uses sepal length and petal width, but the top right uses sepal length and petal width, but in x and y instead of y and x. In the middle, obviously, since sepal length and sepal length are the exact same variable, it'll show an even line distribution because that's exactly what the variable is showing. Now, the other type of graph is the sns.joint grid. It's similar to the joint plot, but it also has a level, but it's quite similar to the joint plot except that it has different syntax. You use the same exact variable assignment, and then you input the first side plot and the middle plot, exactly like joint plot. Finally, the facet grid. Now, the facet grid has different ones. You first use the data frame name, then col equals, and then row equals. It's similar to x and y, except you're using different names to denote input. And you use, again, the map function like we mentioned with pair grid, and then you map the type of plot. In this case, we've used a scatter plot. Now let's go to style. Now, style is actually quite important and useful when creating different plots and how they look, and that might be extremely helpful when beautifying your plots. I just set out a list of some examples of types of style. So you can set style to be different types, and you can definitely find more lists online. But the basics are, there's sns.setStyle, white. You can also do different colors like red, blue. And some examples of style, you can also put ticks, which changes the tick marks. Next, sns.dspline removes the majority of the lines. Take, for example, in a graph like this. You can take out all these lines at 10, 20, 30, and 40, and 50. Next, plt.figure fig size is a use in matplotlib, but it's also quite important in Seaborn because you use plt.figure to create graphs. In this case, you can change the fig size to be whatever you want or whatever is necessary. Finally, sns.setContext is you can change the scale, the type, unconventional terms that usually don't have their own commands. A quick note is that style is not something that can be taught in detail. The internet is your best friend for finding specific minuscule style details. Say you want to change the hue of your thing to be like a certain pink. Well, the internet and places like open coding forums can allow you to find different styles and different sets that you want to create. The final type of plot we'll be going over is the regression plot. Now, what are regression plots? Regression plots are plots that emphasize and visualize patterns in datasets. Unlike distribution, matrix, and categorical plots, they aren't going to give you data for you to visualize and parse. Regression plots themselves will show you patterns, and we'll see this with the use of a KDE and other variations. It is quite useful in an application like machine learning where you use networks and code to find patterns. Now, the most important, or perhaps the only important regression plot that we'll be using is the LM plot. It's sns.lmplot and then x, y, and data, quite similar to previous plots. It creates a regression plot, and as you can see, it uses the scatter plots and then adds a regression line, with also accounting for errors and variability. You can use this trend line to predict future variables, and this is extremely important when the rudimentary basics of your code, when you want to figure out what are you going to predict, or whether your predictions might be close to correct, just based on looking. So thank you very much for listening to this lecture, and I hope you enjoyed learning about Seaborn. In the upcoming lecture, we'll be going over quick implementation and the basics of Seaborn. I'll be going over examples of graphs, not all of them, but ensuring that you have a basic grasp over Seaborn. If you have any questions, feel free again to check out the implementation video or feel free to reach out to the SMLC. Thank you very much.